This video is an instructional tool owned by the Division of Negros Oriental. The division acknowledges the intellectual property rights of the owner of the pictures, illustrations, music, and other similar materials used. This video is made to address the need of grade 11 learners of Negros Oriental, especially in this time of pandemic.
Hello everyone! I am Mrs. Bungabong, but just call me Mambong. I am here to help you develop your mathematics skills, guaranteed that I would be of great assistance. Today, you will be learning on how to determine the intercepts, zeros, and asymptotes of logarithmic functions. But don't worry, for I will be with you every step of the way. So, get ready with your pen and paper. Let's do this. The ability to learn is a gift from God, but the willingness to learn is in your hand. For this lesson, you need to have a background knowledge on the properties of logarithms and laws of logarithms. So, take note of these properties. Number 1. Logarithm of a product. The logarithm of a product is the sum of the logarithms. Number 2. Logarithm of a quotient. The logarithm of a quotient is a difference of the logarithms. Number 3. Logarithm of a power. The power n becomes a factor. On the other hand, here are the laws of logarithms. When b is greater than 0, but b is not equal to 1, and m, n, and k are real numbers, but m and n must be positive. Number 1. The logarithm of the quantity m times n to the base b equals the logarithm of m to the base b plus the logarithm of n to the base b. Number 2. The logarithm of the quantity m over n to the base b equals the logarithm of m to the base b minus the logarithm of n to the base b. Number 3. The logarithm of the quantity m to the power of k to the base b equals k times the logarithm of m to the base b. Number 4. The logarithm of 1 to the base b equals 0. Number 5. The logarithm of b to the base b equals 1. Number 6. The logarithm of the quantity b to the power of k to the base b equals k. Number 7. b to the power of the logarithm of k to the base b equals k. That's it. Those are the things we need to remember for this lesson. Now, let's continue with our discussion. Okay, let's go! Let us start first with the intercepts of logarithmic functions. Intercepts are the points of intersection of the graph to the axis. The first one is the x-intercept. X-intercept. It is the point where the graph crosses the x-axis. This is also called root, solution, or zero of a function. It can easily be solved by simply setting y equals 0. The next one is the y-intercept. It is the point where the graph crosses the y-axis. It can be solved by setting x equals 0. Let us have the first example. Y equals the logarithm of x to the base 2. Let's start with the x-intercept. Just copy the given, but switch their places. So, it will become logarithm of x to the base 2 equals y. First step, let y equals 0. Second step, solve for x. To solve for x, convert this logarithmic function into exponential form. So, from the base 2 raised to 0 equals x. Thus, we now have 2 to the power of 0 equals x. Now, 2 raised to 0 is 1. Correct. We know that any number except 0 raised to 0 equals 1. So, 1 equals x. Our x is 1 and our y is 0. Therefore, our x-intercept is 1, 0. This means that the graph will cross the x-axis at 1, 0. 1 here is also called the 0 of the function because this is the value of x when you set your function equal to 0. Next is the y-intercept. Simply copy the function. So we have the logarithmic function y equals the logarithm of x to the base 2. First step, let x equals 0. So, I replace x with 0. We now have y equals the logarithm of 0 to the base 2. Second step, solve for y. Remember in logarithm, the value of your argument should be greater than 0. But this is equal to 0. Therefore, our logarithm is not defined. Hence, we do not have y-intercept. This means that our graph will not cross the y-axis. Let's take a look at the next example. Y equals the logarithm of the quantity x plus 9 to the base 3 minus 1. Again, let's start with the x-intercept. Just copy the given, but switch their places. So we now have the logarithm of the quantity x plus 9 to the base 3 minus 1 equals y. First step, let y equals 0. So, the logarithm of the quantity x plus 9 to the base 3 minus 1 equals 0. Second step, solve for x. To solve for x, move the constant to the other side. So, negative 1 will now become positive 1. We now have the logarithm of the quantity x plus 9 to the base 3 equals 1. Next step, convert this logarithmic function into exponential form. So, from the base 3 raised to 1 equals x plus 9. 3 raised to 1 equals x plus 9. 3 raised to 1 equals 3. So we now have 3 equals x plus 9. Since we are solving for x, let us transpose positive 9 to the other side. So, it will become negative 9. We now have 3 minus 9 equals x. 3 minus 9 equals negative 6. Thus, we have negative 6 equals x. Our x is negative 6 and our y is 0. Therefore, the x-intercept is negative 6, 0. This means that the graph will cross the x-axis at negative 6, 0. Also, negative 6 is the 0 of the function. Next, y-intercept. Once again, just copy the function. So we have y equals the logarithm of the quantity x plus 9 to the base 3 minus 1. First step, let x equals 0. So I replace x with 0. Thus, we have y equals the logarithm of the quantity 0 plus 9 to the base 3 minus 1. 0 plus 9 equals 9. So, y equals the logarithm of 9 to the base 3 minus 1. I will express 9 as 3 to the power of 2. In this manner, my x and b are the same. Recall the property of logarithm, which states that when x and b are the same, the answer to the expression is the exponent of x. So, the expression logarithm of 3 to the power of 2 to the base 3 equals 2. By substitution, we have y equals 2 minus 1 equals 1. So, our x is 0 and our y is 1. Therefore, our y-intercept is 0, 1. This means that the graph will cross the y-axis at point 0, 1. Now, it's your turn. For this logarithmic function, determine the x and y intercepts. I will read the function. Y equals the logarithm of the quantity x minus 1 to the base 2 minus 4. You have 1 minute to do it. Time starts now. Time is up. Let's check your answer. Let's start with the x-intercept. Just copy the given, but switch their places. So, we now have the logarithm of the quantity x minus 1 to the base 2 minus 4 equals y. First step, let y equals 0. So we now have the logarithm of the quantity x minus 1 to the base 2 minus 4 equals 0. Second step, solve for x. To solve for x, move the constant to the other side. So, negative 4 will now become positive 4. We now have the logarithm of the quantity x minus 1 to the base 2 equals 4. Next step, convert this logarithmic function into exponential form. So, from the base 2 raised to 4 equals x minus 1. 2 raised to 4 equals 16. So, 16 equals x minus 1. Since we are solving for x, let us transpose 1 to the other side. So, we now have 16 plus 1 equals x. 16 plus 1 is 17. So, 17 equals x. Our x is 17 and our y is 0. Therefore, the x-intercept is 17, 0. This means that the graph will cross the x-axis at point 17, 0. Also, 17 is the 0 of the function. Next, y-intercept. Again, just copy the function. So our function is y equals the logarithm of the quantity x minus 1 to the base 2 minus 4. First step, let x equals 0. So I replace x with 0. Thus, we have y equals the logarithm of the quantity 0 minus 1 to the base 2 minus 4. Second step, solve for y. Once again, our argument should be greater than 0. But our argument here is negative 1. Because 0 minus 1 is negative 1. So our logarithm is not defined. Therefore, we do not have y-intercept. This means our graph will not cross the y-axis. Wow! That was a good start! You amazed me! Now, let's move on to asymptotes. Asymptotes are drawn as dashed lines, to which a graph gets closer and closer as the x or y increases or decreases its value without bound. Asymptotes also serve as the boundary lines in which the graph of the function approaches. There are three kinds of asymptotes. Number 1, vertical asymptote. Number 2, horizontal asymptote. And number 3, slant or oblique asymptote. However, logarithmic functions only have vertical asymptote. Now, let's define vertical asymptote. Vertical asymptote of logarithmic functions is graphed as vertical dashed line. It is the value of x as the graph approaches towards positive or negative infinity. In order to solve for the vertical asymptote of the logarithmic functions, simply equate the argument equal to 0 and solve for the value of x. Let's have the following examples. Number 1, y equals the logarithm of x to the base 2. Our argument here is x. So, we will equate x to 0. That is, x equals 0. Therefore, our vertical asymptote is x equals 0. Another example, f of x equals the logarithm of the quantity x minus 3 to the base 1/2. Our argument here is x minus 3. So, we will equate x minus 3 to 0. That is, x minus 3 equals 0. Then, we will solve for x. We will transpose negative 3 to the other side. Now, we have x equals 3. Therefore, the vertical asymptote is x equals 3. Now it's your turn. Determine the vertical asymptote of this logarithmic function. I will read the function. G of x equals the negative logarithm of the quantity x plus 5 to the base 3 minus 3. You have 30 seconds to do it. Time is up. Let's check your answer. Our argument is x plus 5. Equate this to 0. We have x plus 5 equals 0. Solving for x, we will transpose 5 to the other side. So we have x equals negative 5. Our vertical asymptote is x equals negative 5. That was awesome! You are really a fast learner. I can see that you find it easy to determine the asymptotes of logarithmic functions. Salute! As a summary of what we have discussed today, we have to determine the zero of a function, same steps in solving for the x-intercept. To determine the x-intercept, set y equals 0 and solve for x. To determine the y-intercept, set x equals 0 and solve for y. To determine the vertical asymptote, set the argument equal to 0, then solve for the value of x. Now, let's try to see if you can determine the intercepts, zeros, and asymptotes of logarithmic functions. You can do this. Here is what you are going to do. Determine the x and y intercepts, zeros, and vertical asymptote of the given logarithmic function. I will read the function. Y equals the logarithm of the quantity x minus 3 to the base 2 minus 3. You are given 3 minutes to do it. Time starts now. Now, let's check your answer. The x-intercept of the given function is x equals 11 and our y is 0. So we have 11, 0. This means that the graph will pass through the x-axis at point 11, 0. Also, 11 is the 0 of the function. Y-intercept. Since our argument is less than 0, the function is not defined. Therefore, there is no y-intercept. This means that the graph will not pass through the y-axis. For the vertical asymptote, we have x equals 3. I know you got the correct answers. Congratulations! Wow! You are really doing great! Thank you so much for learning with me. So you see, with hard work and the right mindset, math would be fun. Once again, this is Mambong telling you that math simplifies your life and multiplies your opportunities. So learn to love math. And always remember, ang batang alerto sa numero, ganado! See you real soon! Bye!